Welcome to Study Loop.
Okay. In this problem, we're presented with a brass rod of a certain length and diameter. It goes through a temperature change, and we're asked what force is needed to keep the bar from contracting. So this is a thermal stress problem, and our relevant equation is force over cross-sectional area equals the opposite of Young's modulus for whatever material times the coefficient of linear expansion times change in temperature. So let's make sure this is the equation for us. We have force. That's what we're looking for. So it better be in the equation. Cross-sectional area. We're not given this, but we're given the diameter. So we can easily find that. Young's modulus. That's based on the material. We're told it's a brass rod. So we can, or you can, look up the Young's modulus in a table in your physics textbook. Same with the coefficient for linear expansion. Change in temperature. We don't have, but we do have the final and initial temperatures. So that's easy to find. Okay, so let's start finding our values. So for our area, it's a circle. So it's pi r squared, where r is the radius, and radius is half the diameter. And they give us a diameter of 1.6 centimeters, but we're going to want to change that to meters because that's our standard units, and it's just going to make our life easier. It's 0.016 meters times 2, and we divide it by 2, which is going to be 0.008 meters. Plug that back in up here. And yeah, so then our units there will be meters squared. For Young's modulus of brass, you can just go to the table in your book and it'll tell you that it's 9.0 times 10 to the 10th pascals. And our coefficient of linear expansion, if you go to the, for brass, go to the table, and it is 2.0 times 10 to the negative 5th per degree Celsius. So that's kind of a weird unit, but it basically is like per degree Celsius. It'll cancel out the degree Celsius. And lastly, we have our change in temperature. It's going to be our final temperature minus our initial temperature. And it's already in Celsius, which is good for us. It's 10 minus 120 degrees Celsius equals negative 110 degrees Celsius. Okay. So that's all the values we need, and now we have to put them together. Down here, I rewrote the equation solving for force because that's what we're looking for. And if you plug in all your values, you'll get this. But before we plug all this into our calculator, we have to check our units. So we have this per Celsius and Celsius are going to cancel out. And now we have pascals and meters. So what you should know is that pascals are equivalent to newtons over meters squared. And in that case, meters squared will cancel out and we will be left with newtons, which is a unit of force, and that's what we want. Okay, you plug all the numbers into your calculator and multiply it out, you're going to get something like 39,810, not going to worry about decimals, newtons, or in scientific notation, 3.9810 times 10 to the fourth. And we're almost done, but you don't want to forget about significant figures. Based on the stuff that they give us, you have two significant figures in your Young's modulus and your Young's modulus and your coefficient of linear expansion, and so we're limited by that. So you want to round it to two figures, and you're going to end up with 4.0 times 10 to the fourth newtons. And yeah, that